There is an object moving through interstellar space right now at roughly 55,000 kilometers per hour. It has been moving continuously since August 20th, 1977. It has never stopped. It has never slowed down in any meaningful sense. It has passed Jupiter, Saturn, Uranus, Neptune, and then kept going through the boundary of our solar system and out into the space between the stars. It is powered by plutonium that is slowly decaying. Its instruments are shutting down one by one as engineers on Earth turn them off to conserve what little power remains. Its antenna, a dish 3.7 meters across, is pointed at a pale blue dot 19 billion kilometers behind it. And sometime in the next few years, perhaps as early as 2026 or as late as 2030, the last instrument will go dark, the last signal will fade, and Voyager 2 will become a silent piece of metal drifting through the darkness forever. It will never stop. It will never fall into a star. It will never be captured by anything. It will simply drift for billions of years, long after the Earth is gone, long after the Sun has swelled into a red giant and swallowed the inner planets. Voyager 2 will still be moving through the interstellar void. The same object, launched by human hands in 1977, carrying a golden record with the sounds of Earth, still traveling in silence through the dark between the stars. This is the story of where Voyager 2 is going, and what it means that we built something that will outlast everything we have ever made, everything we have ever been, and possibly everything our sun will ever produce. Let us start with where it is right now, because the number is almost impossible to process. As of 2025, Voyager 2 is approximately 19 billion kilometers from Earth. Light, the fastest thing that exists, takes roughly 17.5 hours to cover that distance. When you send a command to Voyager 2, you wait 17.5 hours for it to arrive. Then you wait another 17.5 hours for the response to come back. A single exchange takes 35 hours. The engineers who manage the mission do not think in minutes or hours, they think in days. A simple software update becomes a multi-week project when every instruction must survive a 17-hour journey before it can be confirmed. And Voyager 2 will never slow down, not in any meaningful sense. Its engines exhausted their fuel for course corrections long ago, but in the vacuum of space there is no friction, no air resistance, nothing to bleed away its velocity. The same push that put it on its way in 1977 is still carrying it forward today. This is one of the fundamental facts of space that the human mind struggles to fully accept. In space, things that are moving keep moving, forever, unless something stops them, and nothing in Voyager 2's path is going to stop it. Voyager 2 crossed the heliopause in November 2018. The heliopause is the boundary where the solar wind, the constant stream of charged particles flowing outward from the Sun, loses enough energy that it can no longer push against the interstellar medium. Beyond that boundary, the Sun's influence effectively ends. The space Voyager 2 is now traveling through is not empty. It is filled with the thin gas and dust of the interstellar medium, the material between the stars, and the measurements Voyager 2 sent back as it crossed the heliopause were not what scientists expected. The boundary was sharper than models predicted. The transition from the heliosphere to interstellar space happened over a much shorter distance than expected. The magnetic field direction changed abruptly. The particle density shifted in ways that suggested the interstellar medium was pushing back against the solar wind more actively than anyone had anticipated. These were not catastrophic surprises, but they were surprises. The edge of our solar system does not look quite like the models said it would, and Voyager 2 is the only spacecraft to have measured it directly, because Voyager 1, which crossed the heliopause earlier in 2012, did so with a failed plasma science instrument. The instrument that would have measured exactly what Voyager 2 measured had already stopped working on Voyager 1. The data Voyager 2 returned from the heliopause crossing is irreplaceable. It is the only complete direct measurement of that boundary humanity has ever made. Before we talk about where Voyager 2 is going, it is worth talking about what almost ended the mission early and how NASA saved it. In July 2023, a series of commands sent to Voyager 2 accidentally caused the spacecraft's antenna to tilt 2 degrees away from Earth. 2 degrees. In everyday life, 2 degrees is nothing. On a spacecraft 19 billion kilometers away, 2 degrees meant that Voyager 2's signal could no longer reach the Deep Space Network antennas on Earth. The spacecraft went silent. For the first time since its launch in 1977, there was no signal from Voyager 2. Engineers could send commands, but they could not know if they were being received. They could not hear a response. For several weeks, Voyager 2 was effectively lost, transmitting into a void with no confirmation that anyone was listening. NASA's response demonstrated something remarkable about both the engineering and the people behind the mission. Rather than waiting for the spacecraft's onboard systems to execute an automatic reset, which was scheduled but uncertain, engineers used the Deep Space Network's most powerful transmitter to send a command directly to Voyager 2. The command was simple: reorient the antenna, point home. The signal took 17.5 hours to reach the spacecraft. Then another 17.5 hours for any response to return. Engineers waited 35 hours, not knowing if the command had been received, not knowing if the spacecraft would respond. And then the signal came back. Voyager 2 had heard them. The antenna was reoriented, contact was restored. A spacecraft 19 billion kilometers away, running on less power than a light bulb, responded to a whisper across the void. The crisis lasted weeks. To the casual observer, it was a brief news story. To the small team of engineers who managed the Voyager missions, it was the most stressful period in recent memory. These are people who have, in some cases, worked on the Voyager missions for decades, who know the spacecraft systems as intimately as any engineer can know a machine they have never touched and never seen in operation, who communicate with it across distances that make the word communication feel like a euphemism, and who, for a few weeks in 2023, did not know if they would ever hear from it again. Now Voyager 2 is in interstellar space, moving away from the Sun at roughly 15 kilometers per second, and what lies ahead of it in that direction is, on the scale of human experience, nothing. Stars are separated by such enormous distances that even moving at 55,000 kilometers per hour, it will take Voyager 2 tens of thousands of years to come anywhere near another star. In those tens of thousands of years, civilizations will rise and fall. The Earth's climate will shift through ice ages and warm periods. The continents will move. The Himalayas will erode. Species that do not exist yet will evolve, flourish, and go extinct. And Voyager 2 will still be moving through the same interstellar darkness, a fraction of the way through a journey that has no destination. There is one more thing worth understanding about Voyager 2's position before we talk about its final destination. In February 1990, when Voyager 1 was about 6 billion kilometers from Earth, NASA turned its camera around one last time and photographed the solar system from the outside. Earth appeared as a pale blue dot, less than a pixel across, barely visible in a scattered beam of sunlight. Carl Sagan wrote movingly about that image, noting that all of human history had occurred on that tiny point of light. Voyager 2 is now more than 3 times further away than Voyager 1 was when that photograph was taken. If it turned its camera around today, Earth would not register as a pixel at all. It would be invisible against the background of stars. The question of where Voyager 2 is going is therefore not a question with a satisfying answer. It is going into the Milky Way, into the disk of the galaxy, drifting slowly relative to the Sun in the direction of the constellation Telescopium. It will pass near Ross 248 in roughly 40,000 years. In roughly 296,000 years, it will pass within 4.3 light-years of Sirius, the brightest star in the night sky. In millions of years, it will drift through regions of the galaxy that have no names because no human has ever thought to name them. Its speed, which seems extraordinary on a human scale, is trivially slow on a galactic scale. The galaxy is 100,000 light-years across. Voyager 2, traveling at its current speed, would take approximately 2 billion years to cross it. The Sun will be a red giant, and the Earth will be gone before Voyager 2 gets anywhere remotely close to the other side. But let us talk about what happens before the silence. Because there is still a story being told right now, and it is nearly over. Voyager 2 is powered by 3 radioisotope thermoelectric generators, RTGs. They convert the heat produced by the radioactive decay of plutonium-238 into electricity. Plutonium-238 has a half-life of 87.7 years. This means that every 87.7 years, the power output of each RTG drops by half. Voyager 2 launched with RTGs producing roughly 470 watts of electrical power. By 2025, that output had dropped to approximately 70 watts. A single household light bulb uses 60 watts. The spacecraft that has traveled further than almost any object in human history, that has sent back data from the edge of the solar system, that carries a golden record with greetings in 55 languages, is running on less power than it takes to keep a reading lamp lit. Because of this power constraint, NASA has been systematically shutting down Voyager 2's instruments. The Plasma Science Instrument, which measures charged particles in the solar wind and interstellar medium, was turned off in 2024 to conserve power for the remaining science instruments. The Cosmic Ray Subsystem and the Low-Energy Charged Particle Instrument are still operating. The magnetometer is still operating. The plasma wave subsystem is still operating. Each remaining instrument provides data that cannot be obtained any other way. The interstellar medium measurements coming from Voyager 2 right now are unique. No other spacecraft is where Voyager 2 is. No mission currently planned will reach interstellar space within our lifetime. Whatever Voyager 2 is measuring in the darkness beyond the heliopause, it is measuring alone. The final instrument shutdown will come sometime before 2030. Engineers will turn off the last operating system, not because the mission is complete, but because there is simply no longer enough power to transmit data back to Earth. The spacecraft will continue operating in a minimal sense, the computers still running their basic functions, the antenna still nominally pointed at Earth, but there will be nothing left to say. And even if there were, the signal would arrive at Earth as silence, too faint to distinguish from background noise. And then Voyager 2 will continue, silently, forever. This is where the story becomes something other than a science story, because the spacecraft that will drift through interstellar space for billions of years is carrying something. Strapped to its frame is a 12-inch gold-plated copper disc. On it are 115 images of Earth, its people, its landscapes, its cities, greetings in 55 human languages and 1 whale language, 90 minutes of music from cultures across the world, including Bach, Beethoven, Chuck Berry and Azerbaijani bagpipes, the sounds of rain, wind, thunder, breaking surf, a mother's first words to a newborn child, and the brainwaves of a woman thinking about her life. Instructions encoded in binary for how to play the record and where in the galaxy it came from. Carl Sagan, who conceived the golden record, described it as a message in a bottle cast into the cosmic ocean. A way of saying, to whoever or whatever might find it in the incomprehensible future, that we existed, that we were here, that we looked out at the universe and tried to send something of ourselves into it. The chances of the golden record being found are essentially zero. Not because space is not vast enough to contain other intelligence, but because space is so vast that even a deliberate search by a technological civilization would have almost no chance of intercepting an object this small, moving through the interstellar void. The golden record is not a message sent to a recipient. It is a message sent to the universe without expectation of reply, as a statement rather than a communication. We existed. We thought about you. We hoped you might exist too. When Voyager 2 finally goes silent, it will not be a failure. It will be the completion of something that exceeded every expectation anyone had for it when it launched in 1977. It was designed for a 4-year mission to Jupiter and Saturn. It has been operating for nearly 50 years. It has visited 4 planets, discovered new moons, returned data that rewrote textbooks on planetary science, crossed into interstellar space, and measured an environment that no instrument had ever reached before. Its last data will arrive at Earth as a gradual fading, signal dropping into noise, and then nothing. And then Voyager 2 will be alone in a way that nothing human-made has ever been alone before. No signal reaching it, no instruction coming from Earth. Just a piece of metal and a golden record, moving through the dark at 55,000 kilometers per hour, carrying the sounds of a world that will be long gone before it gets anywhere near its next close encounter with a star. There is something in this that resists easy description. Not sadness exactly, not triumph, something between them. The knowledge that we built something that will outlast us, that will outlast our cities, our languages, our sun, that carries with it a record of what we were, what we sounded like, what we found beautiful enough to send into the void. The knowledge that the universe, which does not care about us in any meaningful sense, will carry our message anyway, in the hull of a small spacecraft, for billions of years through the silence between the stars. Voyager 2 is still out there, still transmitting. For a little while longer, the dish is still pointed home, and there is still something to say. Listen while you can. If you enjoyed this video, consider subscribing. I will see you in the next one.